Imagine an e-commerce application where the mobile app directly calls order, payment, inventory, user, and shipping services. At first, this may look simple. But as the system grows, every client becomes dependent on internal service locations and APIs. If a service moves, scales, or changes, clients may also need changes. So the real question is, should every client know the complete backend architecture? In this video, we will solve that problem using the API Gateway pattern. Imagine an e-commerce application with order, inventory, payment, and shipping services. A single customer action may involve several microservices. If the web or mobile app calls each service directly, the client becomes tightly coupled to the backend. It must know which service to call and where it is running. As the system grows, this becomes difficult to maintain. So, should every client know the complete internal architecture? Ideally, no. An API gateway acts as a controlled entry point between clients and microservices. Instead of exposing every internal service directly, clients communicate with the gateway. It routes each request to the correct service and can apply common policies such as security and rate limiting. This reduces client coupling and hides internal service details. The client only needs to know the gateway, while the gateway manages communication with backend services. Let's follow one request. Suppose the client sends get/API/orders/101. The request first reaches the API gateway. The gateway can authenticate the request, identify the destination, apply policies such as rate limiting, and then route the request to the order service. The service processes the request and sends the response back through the gateway. The client does not need to know the internal server address. This separation makes the system easier to evolve and manage. The API gateway handles common API concerns such as request routing, authentication, rate limiting, logging, metrics, and API versioning. With Spring Cloud Gateway, requests can be routed to services using defined paths and service names. The gateway manages traffic and shared policies, while business logic stays inside the microservices. This keeps the gateway focused and prevents it from becoming another business layer. What happens if the API gateway goes down? Even when the backend microservices are healthy, clients may not be able to reach them. This makes the gateway a critical dependency. A single gateway instance can become a single point of failure. In production, we should use multiple gateway instances, health checks, and load balancing. The goal is to keep the gateway highly available and prevent one failure from affecting the entire system. In production, we should avoid relying on a single API gateway. Multiple gateway instances can run behind a load balancer, with health checks removing unhealthy instances. The gateway can scale horizontally as traffic increases. We also need security, rate limiting, logging, metrics, and monitoring. This design provides high availability while allowing the gateway to manage traffic without becoming a single point of failure. A common mistake is putting business logic inside the API gateway. Business rules should remain inside the microservices. Other mistakes include using only one gateway instance, having no monitoring, or ignoring rate limiting. The gateway simplifies clients, but it also adds responsibility and processing overhead. Too much functionality can make it a bottleneck. Keep the gateway focused, lightweight, observable, and highly available. If an interviewer asks why we need an API gateway, answer this: An API gateway provides a controlled entry point between clients and microservices. It handles routing, authentication, rate limiting, API versioning, and observability. It also hides internal service details from clients. Business logic should remain inside the microservices, and the gateway must be highly available. Be ready for questions about gateway failure, load balancing, service discovery, and authorization. Remember 5 things. The API gateway is the controlled entry point for clients. It handles routing and common API concerns. Business logic belongs inside the microservices. The gateway must be highly available. Service discovery helps locate dynamic service instances. Now we have the next question. When the gateway receives an orders request, how does it find the correct running service? That is what we will solve in day 4.